Post-harvest water systems are critical components of fresh produce packing operations. These systems include various water contact processes such as dump tanks, flumes, and hydrocoolers. Their primary roles are to remove soil, plant debris, and field heat, enhance produce appearance, and/or facilitate handling and transport. These post-harvest water systems fall into two categories: single-use water and recirculated water. Single-use water is water that contacts produce once and is then discarded. In contrast, recirculated water systems continuously reuse water. While recirculation conserves water and energy, it creates unique challenges since debris and microorganisms from produce, including foodborne pathogens and spoilage organisms, can accumulate in the water over time. This creates a risk of cross-contamination, where microorganisms may transfer from contaminated to uncontaminated produce. While proper water management is not considered a kill step for foodborne pathogens, it does prevent cross-contamination. Because recirculated water systems continuously reuse water, it's critical to ensure that these systems effectively control microbial hazards under real operating conditions. This is where validation comes into play. What is validation? Validation is the scientific process of obtaining and evaluating scientific evidence to confirm that a specific control measure, process, or system consistently achieves its intended outcome. In this case, effectively controlling microbial hazards in a post-harvest water system under operating conditions. It involves systematic monitoring of both the water and the produce over time to determine if microbial contamination is prevented or minimized. Validation versus verification. It is important to distinguish validation from verification. Validation confirms that the process, as designed, can achieve the desired microbial control under actual operating conditions. It addresses, am I doing the right thing? Whereas verification ensures that the validated process is implemented correctly and consistently, addressing, am I doing the thing right? Both are essential components of a robust food safety management system, but validation provides the foundational evidence that the control measures are effective. To mitigate cross-contamination risks in recirculated water systems, sanitizers such as chlorine or peroxyacetic acid, often abbreviated PAA, are commonly added to water. These antimicrobial agents inactivate microorganisms in the water, helping to maintain microbial safety. However, sanitizer effectiveness depends on a complex combination of factors, including water chemistry parameters such as pH, temperature, and organic load, as well as operational factors like contact time and sanitizer dose. Because of this complexity, sanitizer manufacturers provide efficacy data based on controlled laboratory conditions, which may not fully represent real-world packing house environments where organic loads and water conditions vary widely throughout the day. Therefore, in-field validation studies are critical for each individual packing operation to confirm that the chosen sanitizer and concentration effectively control microbial hazards under actual processing conditions. This is also beneficial in helping identify appropriate water change schedules and develop scientifically supported monitoring protocols. In-field validation ensures that sanitizer use is not only theoretically effective, but practically reliable, preventing cross-contamination. Conducting an in-field validation study. A proper validation study for a recirculated post-harvest water system typically includes sampling incoming produce, outgoing produce, and recirculated water at regular intervals over the entire hold duration from each discrete water system, for example, individual, separate water systems within the packing house, which operate independently of one another. Monitoring indicator microorganisms such as aerobic plate counts, Enterobacteriaceae, or total coliforms, confirming that microbial populations remain stable or decrease after each water system, and measuring sanitizer concentrations to verify they consistently meet or exceed minimum effective levels throughout operation. This validation process provides food safety teams with objective evidence that the water system effectively controls microbial hazards, preventing cross-contamination. It can also help define water change schedules tailored to the specific packing house and commodity by showing when continued sanitizer additions no longer maintain water quality and microbial control. It's important to note that validation typically only needs to be performed once per water system, as long as the process, equipment, sanitizer type, and dosing and produce commodity remain unchanged. However, validation should be repeated if any significant changes occur in the system, or if an auditor, buyer, or regulatory authority requests updated data. To support the industry, a team of experts is developing a clear, standardized validation protocol for produce packing houses. This protocol is designed to be scientifically sound, practical for on-site use, and widely accepted. Along with the protocol, resources such as instructional videos on proper sampling techniques, example datasets with explanations, and step-by-step guides for documenting validation studies are being created. The goal is to make validation easier and more consistent across operations, offering practical support for effectively managing post-harvest water systems.